Hello everyone, I am Kamana Mishra from the Department of Physics, IIT BHU. Title of my presentation is Study the Catalytic Behavior of Hydrothermal Processed NiO, that is nickel oxide. Now, I have done this work under the supervision of Dr. Prabhakar Singh sir, and I am very grateful for his guidance and support throughout my work. I would also like to thank Dr. Priyanka ma'am and Dr. Pradeep sir for their support, and a special thanks to Manisha ma'am for explaining each and every experiment to me. Now I would like to start my presentation. These are the outlines which I'll be going through. First of all, I would like to explain what is nanotechnology and why do we prefer nanoparticles over bulk material. So nanotechnology is the branch that deals with the dimensions of less than 100 nanometer, and the importance of these materials realized when researchers found that size can influence the physiochemical properties of a substance like optical properties and other properties also. And nanoparticles have several advantages over bulk materials, such as the use surface to volume ratio, very high porosity, and completely different physiochemical properties. That is why application of nanoparticles in sensing and biosensing have increased rapidly in recent years, owing to their unique physical, chemical, and electrochemical properties. Electrochemical performance of several metal oxides have been already studied, like manganese oxide, cobalt oxide, tin oxide, nickel oxide, and ferrous oxide. But among these oxides, nickel oxide shows good electrochemical performance and also have gained attention due to its magnetic, mechanical, electronic, and optical properties. Now, these are the synthesis methods of anion nanoparticles, because nanoparticle applications do not depend only on the size, morphology, and the structure, but also depend on the method of synthesis employed. There are several methods to synthesize anion nanoparticles, and all the methods are listed here. And this image shows different methods used to prepare several nanostructural forms. We have chosen hydrothermal synthesis method over other methods because it is beneficial for producing highly crystallized nanopowders with high purity without any heat treatment in a short time. These are the physical properties of NiO. The main focus of our work is to study electrochemical behavior of nanostructured nickel oxide. Nickel oxide is a transition metal oxide with a band gap ranging from 3.6 electron volt to 4 electron volt, and it has conduction band energy of 1.8 electron volt, ionization potential 10.7 electron volt, and it has very high specific capacitance, that is 2584 Fad per gram. Now, the structure of NiO is shown here. It has a FCC crystal structure, and it also exhibits electrochemical stability, anodic electrochromism, large spin optical stability, excellent durability, and various manufacturing possibility. Practically, NiO tend to have low conductivity, low electronic conductivity, and so they are combined with other components that can increase its conductivity, such as CNT, graphene, and metal oxides. If we talk about other properties, then morphology and particle size of a sample or NIU have significant effect on the capacitance. Smaller the size of the particle, more will be the conductance. And crystallinity also plays a crucial role in pseudo-capacitance of electrode material. Low crystallinity means large capacitance, as it provides more diffusion channels for electrolyte ions. And if we talk about electrical properties, then electrical properties are influenced by the size of the nanoparticle. Bigger grain results in less grain boundaries, as we know this already, and which affect electrical conductivity because scattering effect at a grain boundary is reduced. Now let's talk about the optical properties. So the band gap of NIO comes out to be 3.6 electron volt to 4 electron volt, and the energy gap of semiconductor decreases with the increase of grain size of nanoparticle. Now, this is the literature review, which shows different synthesis methods and their corresponding obtained nanostructure, particle size, and surface area. So we can see that different methods lead to different nanostructures and different particle size accordingly. Now I'll be explaining my experimental work and analysis. Objective of my work is to synthesize and study the electrochemical behavior of nickel oxide nanoparticles for various applications. And I have done the structural analysis by using Xrd technique and UV-Vis analysis to calculate the band gap of the sample, and have done the cyclic voltammetry experiment to study the electrochemical behavior. Now this is the experimental technique which I have done. So I have taken a nickel nitrate hexahydrate as a starting material, and then this was dissolved in distilled water, then transferred into autoclave, and the solution was kept there for at 130 degrees centigrade for 48 hours. And after 48 hours, the solution which we obtained from the autoclave, in the solution NaOH was added, and then obtained solution or the mixture of nickel nitrate and NaOH was washed with distilled water several times and then dried at 150 degrees centigrade for 2.5 hours. So this is the flow chart of the processes which I have gone through, and and as we can see that the powder which I have obtained, this is the nickel oxide hydrothermal processed nano powder, and these are the processes which I have gone through for the hydrothermal process. Now I'll be moving on the characterization techniques, result, and discussion. So this plot shows the Xrd plot for the NIO which I have obtained. I can see that first of all, Xrd. What is Xrd? So Xrd is a technique which is used to examine the phase crystallinity and purity of the sample. And from this plot, as we can see that some of the extra peaks are coming. This dot is showing the NIO peaks, which we already have, but we are getting some extra peaks. This is maybe due to the less heating of the sample. So we are expecting that these extra peaks to be removed after sintering. And and after sintering, the phase will be matched. We are expecting that the phase will be exactly matching with the NIO phases which we already have. Now this is the UV vis study of the NIO, and the band gap calculated from the plot is 1.74 electron volt and 3.04 electron volt. Now, next we have done the electrochemical study of the sample, and we have used cyclic voltammetry to study the electrochemical behavior. So, cyclic voltammetry is actually used to investigate the reduction and oxidation processes of molecular species, and it is a 3-electrode system. First is working electrode, reference electrode, and the third one is counter electrode. So, working electrode is the electrode of our interest where the electrochemical reaction occurs. Next is a reference electrode. So a reference electrode is an electrode whose electrode potential is stable, and it is used as a reference against which the potential of other working electrodes can be measured. And some of the examples of working reference electrodes are AgCl electrode, AzNO3 electrode, and many more are also there. And in our lab, we are using AgCl electrode for reference electrode as a reference electrode. Now, next is counter electrode. So it is used to complete the electric circuit, and current is recorded between the working and counter electrode. An example of counter electrodes are platinum electrode and mesh type platinum electrodes. Now, so this shows the plot obtained from the CV analysis, and as we can see from the plot that the area in the third quadrant is higher than other quadrants, which shows that cathodic current, cathodic current is higher in the sample, and simultaneously oxygen reduction reaction is higher, and these results are in accordance with our application purpose, that is the cathode materials for solid oxide fuel cell. So these are the result and discussions which I have explained, and in general, pure NIO gives peaks index at 111, 200, 220, 311, and 222, and we are expecting that after sintering we will get exactly these peaks only. And my experiment is still going on. Several characterization techniques are still left to analyze in future, and mainly we are trying to find suitable material for a cathode of solid oxide fuel cell. And these are the references which I have used. And thank you for this opportunity. Thank you, everyone.